as you all probably already know, I'm Dylan with InterLink. We've been hosting SolidWorks user group for a while now, but I appreciate, as usual, everyone coming. And if there's anyone new to the group, welcome. And feel free to, jump in and ask questions and stuff when you need. Yeah, we have time for questions, everything at the end of the presentations also. So recently at InterLink, we've gotten a new Haas VF2 machine, and we've been, as you might imagine, spending a lot more time setting up our models for machining, not just designing for machining, which we've been doing obviously for years, but actually more optimizing our setups for the machine to put into our MasterCAM program. Which is what we use in-house in MasterCAM. We don't use the SolidWorks add-in version because it lags behind, and actually I think also maybe not supported officially anymore, or at least not updating. But we still do a lot of setup in SolidWorks before exporting, and we do some, I think possibly interesting things to kind of show you guys what we do. So I'm going to go through that a little bit. And then most of what I'm going to go into is just going to be a demo on SolidWorks, and we're going to be just talking about how we utilize our vise, parallel, stock, and operation configurations for programming. So I'm going to go ahead and just take it out here. So this is essentially a model the way it would start. We have like a template that looks a lot like this with no part in it. So I just hid the part there for a second, but this is essentially what we would open as a starting template for our machine. It's got a piece of stock here, which everything is focused around the stock. The stock is fixed in place on the origin where we want it, which in this case, we treat the origin as the kind of top right of the machine, of the bed. And then we have our vise in here, which we have as if I suppress this for a second. So as a flexible model so that we can show clamping different objects and move things around as necessary. And just for reference, in case somebody doesn't know, I'm just gonna suppress this for a second. If you don't know what flexible is, if you've never used that, that's this button right here. So under your quick menu, make subassembly flexible. So essentially what that's allowing you to do is take something within the assembly. You can move this around, right? This is inside this assembly, you can move this. But if you're in a higher level assembly, where that would be typically locked in position because it's under a separate subassembly where that mate exists, you can actually make it flexible and it allows it to move like you're in that subassembly. Hopefully that makes sense what I'm trying to say there. So we move that around. I'm sorry, say that again? Door hinges. Yeah, door hinges and shocks, great examples, yeah. Yeah, basically sub-assemblies you're trying to move in a higher level assembly. So anyway, yeah, so we have that as a flexible sub-assembly, and then we also have that with multiple configurations built into it. So that's its own sub-assembly with built-in parallels for machining. So these are our parallels, and we have different heights, standard heights built into them. So when we're basically, accommodating all our different tooling already in here, it's not 100% comprehensive still. We're still working on some of our processes, but this has a lot of what we typically use for our setups. So we can quickly change to the different parallels configuration we have. And then for our stock, this is just what it sounds like. It's just intended to be a stock piece of material. We have it driven from equations. So for example, if I actually wanted this, if I needed this to be a 12 by 12 for this part, you know, I would just be changing that equation, trying to make everything really fast and flexible for us. If this needed to be a 2-inch piece of stock, you know, we just change these variables. One of the useful areas or useful parameters here is where is our split line, right? Because our split line, in this case, typically, if I show my part again, needs to be in relation to the part. Split line needs to be above the part so that I can so I can face that, but above the edge of our vise, right? We don't want to collide with the vise while we're machining, particularly in this case because we're not machining steel, we're machining. I mean, you don't generally want to hit your vise in any way, but you especially don't want to hit it when you're thinking you're machining plastic and you're going to tear up your tool. So we need to have that line be in the right spot. So that's another parameter we control in our stock where that split line is going to be. And essentially for a simple part like this and a simple program like this, that's going to determine where our, you know, op1 and op2 split. So with these configurations and our, you know, we essentially mate our part in here where we're expecting it to sit in relation to the vise and the stock. In this case, I've just essentially centered it on the stock. And then a bit within the body here. So I have it offset from this top face a little bit so that we can actually face it, make sure we're getting a nice flat face. And then above that split, like I was saying. But so our op1 is essentially cutting that profile from stock, getting that. And then when we go to op2, we have another vise dropped in. So the other vise is suppressed, this other vise. So everything's based around the stock and the part versus actually treating the vise as the fix. We actually treat the part as a fix. And there's some reasons for that. It's easier for our pathing and stuff to consider that when we're importing multiple versions of this, because ultimately these will all get outputted as a step file and then overlaid, considering where the part is going to be and where our machine datum is, because the part is really put in relation to the machine datum. Anyway, yeah, so op1 is done. Essentially, this part has all these features cut into it, and all we need to do is take off this part of the stock. Now, in reality, this is a little bit of imperfect representation because this pocket hasn't been cut yet. That will be cut. This is a little bit of a simplistic version for us to just use to kind of show the outer boundaries. I don't need to show that this actually would be full of material, or for our purposes, it's more of a visual demonstration. In large part, what it's essentially helping us do, aside from program pathing, is just to verify clearances and stuff. So the fact that we don't show this stock is inside this pocket is sort of immaterial, but that is happening in this op as well, in this operation. So then, yeah, essentially op2 would be facing this and taking that down. It's pretty simple, just op1, op2 kind of representation of how we put that together, and we output our files really quickly in SolidWorks. And the designers can even do this. The other reason we do this, I should say, is the designers can consider these factors quickly and put together this model really quickly without necessarily having to be the ones machining it, but making sure that they've considered certain things here, what stock size we need. Maybe they originally thought they could get away with, you know, let's say 1 5/8 stock, and then they realized, you know what, actually that's not going to give us enough clearance. Now that I've put it in here, I realize, you know, that doesn't give enough clearance. So it's quick little models that they can output as steps, put into our programming files. And even though they're not going to necessarily program it, maybe another person's going to program it, this has already been considered, and it makes the machinist job a lot easier. They already know the setup has been considered and what tooling they're going to need to be using. And maybe there's some back and forth if they disagree, they want to do something different, but there's sort of a baseline created, and it helps the process a lot. So it's kind of a quick overview of some stuff we're doing to try and optimize that new process. Any questions? So I have a.
How long did it take you guys to pick up MasterCAM?
That is an excellent question. Actually not too bad. So we had at least one person, well, multiple people on our team had MasterCAM experience. One person in particular has like 20 years MasterCAM experience. So he's quite an expert. So that obviously helps. But one of the people that's most involved with writing our programs right now really hadn't done much in MasterCAM. But through, obviously having that expert knowledge base there as well already, and, a few quick videos and a little trial and error, was able to pick up a lot of what we need very quickly. We're not doing 5-axis, really intense stuff. Mostly what we're trying to do is quick prototypes, just 3-axis, fairly simple parts. So it hasn't gotten too crazy yet, but yeah, we picked it up pretty quick overall.
So you're saying SolidWorks CAM is not supported anymore?
That's yeah.
Or HSM works?
MasterCAM within SolidWorks, I believe, is no longer being updated. SolidWorks CAM is still available and still going, as far as I know. Yeah. We're using MasterCAM in this case, not SolidWorks CAM. But yeah, I think the SolidWorks CAM, or I'm sorry, the MasterCAM plugin for SolidWorks, I think stopped getting updated in like 2023 or something.
Okay.
Okay, thank you. Yeah, so, but yeah, as a separate program, it still imports everything pretty, easily. It still interfaces well with your SolidWorks models, essentially, just inside the MasterCAM instead. Yeah, any other questions or anything? No? All right, perfect. Well, oh yeah, go ahead, sorry. Yeah, that is a really good question also. So somewhere in between easy and hard. It depends on the change. So if your model has really drastically changed, it's like just start over. It's really not worth it. If it's like, oh, just a depth change or something, oh, this pocket just needs to get a little deeper in this rev, we don't even bother changing the model. We essentially just overwrite the program. But it wouldn't be that hard to just re-import and do a simple change like that. If it's going to, if it's like, hardly recognizable, the part, there's no reason to try and really do a replace. That's a good point. Yeah.
Ooh, that brings back nightmares of years ago.
Yeah.
I'm used to write as an admin, but not HSM works instead of MasterCAM.
Gotcha.
But that's also going to be killed by Autodesk in 27.
Oh, is it?
Yeah, they just sent that email out.
Geez.
Recently.
Yeah, companies sunsetting programs is
well, they want to encourage you to buy their.
Yeah, right. I suspect. I mean, I don't have any insider knowledge here, but I suspect that might be why MasterCAM kind of doesn't, the add-in doesn't update anymore, because SolidWorks CAM sort of
want you to
competing and cannibalizing some of that, so they don't want to play nice together anymore, I guess. But in this case, yeah, part of the reason we're using MasterCAM instead of SolidWorks CAM is we just kind of inherited it and already had a knowledge base for MasterCAM. It wouldn't be a bad thing for us to dig into SolidWorks CAM more, although we've given at least a basic intro to that. I think we have a presentation from a year ago or so. I think Jerry did a little bit of SolidWorks CAM overview. Yeah.
Jerry.
Yeah. So I'm not sure how different it is from MasterCAM in terms of like if skills transfer over really well or not. Cool. All right. Well, if that's all for now, I think I'll let Aaron take over.